Let's look at some solutions. Here we're talking average rate of change. We have example 1. It read, I'm going on a 180-mile trip, and it's going to take me 3 hours. What is my average rate of change? In this case, also known as the average velocity. Easy enough. Distance, change in distance divided by total time, or change in time, gives me 60 miles per hour. Example 2. Example 2 had a ball being dropped straight down from the set of bleachers. Its position was given by S of t, and we kind of use S of t as the standard distance equation here, or namer here for this function. D is sort of taken for derivative in calculus, but we have negative 16 t squared plus 100 as our position function as a function of time. In other words, this is giving us the position at any given time t of the ball as it's being dropped from what you can assume is a height of 100 feet. We're looking to find the average velocity over the first 2 seconds, so we really need the change in distance over change in time. More specifically in this case, s of 2 minus s of 0 over 2 minus 0. Well, 2 minus 0 is easy, that's just going to be 2. If we take 2 and plug this into our function, kind of show that work there and extend our fraction. So we need to evaluate that in just a second. Minus s of 0, putting 0 in here is a pretty easy 100. So that gives us 4 times 16. Take that away from 100. We end up with negative 64 plus 100 minus 100 all over 2, which gives us a total of 32 feet per second. Units make sense there. Change in distance over change in time, feet per second. What happens though when we go to instantaneous rate of change? The example was a ball is dropped straight down from the top of the bleachers. Its position is still given by the same distance equation, or position equation, negative 16 t squared plus 100. Use the derivative of s of t, so s prime of t, to find the instantaneous rate of change at time equals 0 and time equals 2. So s prime of t, using my power rule, gives me negative 32t. The derivative of 100 is 0, so s prime of 0 equals 0, and s prime of 2 is negative 64. That actually, I'm going to walk it back a second. I made an error up here. If those two go away, my average velocity or average rate of change is negative 32 feet per second, which makes perfect sense as I'm on my way down. Interestingly, and this will not always be the case, and kind of the point of this whole scenario is that when we walk these two items through, in this case, it happens that if I average the beginning and end velocities, I end up with the average velocity. That does not always happen. The average rate of change is not equal to the average of the rates of change. They're not equal. That's a big deal.